Okay, here's an example question on drawing the chair conformations of a molecule that I give you, and I'll give the one that I used in this morning's lecture. What I'd like you to do is to take one sec-butyl, 3-ethyl cyclohexane, and I would like you to first of all write the 4 chair conformations that are possible for this molecule. Label each as cis or trans, and then rank them in energy from most to least stable. Okay. So in order to do this, we need to start with chair conformations. So you'll be given on an exam, you'll be given these blank chairs. You'll have to figure out where to put the axial and the equatorial positions. So in this case, I want to start with a sec-butyl group. So you have to remember, what is a sec-butyl group? So I'm going to use the upper right-hand carbon as my number 1 carbon. And so I'm going to attach the sec-butyl group in 2 of the conformations axial and in 2 of them equatorial. Now here's where you have to be careful. You have to make sure that when you write your sec-butyl group, that you actually attach the CH group to the ring. So there's 2 axials, and then down here there's 2 equatorials. And I'm just going to try and squeeze this in here. Okay, so there is the adding the sec-butyl group to the 4 conformations. Okay, so that's what that is going to look like. The other position will get a hydrogen. Now, I want to find the 3 position, and if we go 1, 2, 3, the 3 position is either here or it could be on the other side. I like to put the 3 position here, and I'm going to go ahead and put my axial and my equatorial positions into carbon 3. And so now what I'm going to do is now I'm going to draw out the 4 combinations of having the sec-butyl group and the ethyl group both axial. So here is my ethyl group. They're both axial. The tertiary group axial and the ethyl group equatorial. Over here, the sec-butyl group equatorial and the ethyl group equatorial. And then finally, the sec-butyl equatorial and the ethyl group axial. So those are the 4 combinations. Both groups equatorial, both groups axial, one axial, the other equatorial, and vice versa. So I've drawn the 4 possible conformations. Now the question is, do I have to write in the other hydrogens? I actually don't have to. So I have now completed step 1. Now I need to label each one of these as cis or trans. And remember, cis or trans means, are the two groups on the same side of the ring, or are they on opposite sides of the ring? So if we look at number 1 here, the one farthest to the left, this ethyl group is above or below the plane of the ring? Above. The sec-butyl group is above or below the plane of the ring? Above. They're both above. That's the cis conformation. Okay, the second one, the sec-butyl group is above. The ethyl group is below. Trans. Number 3, sec-butyl group below. Ethyl group below. Cis. Ethyl group above, sec-butyl group below, trans. Okay, so it doesn't matter whether the groups are axial or equatorial. That's not the way you determine cis or trans. You determine cis or trans based on whether the two groups are above or below. And so in this case, we've now labeled each one as cis or trans. Okay, so the next and final step is energies. So the destabilizing interactions in cyclohexanes are when a non-hydrogen group is axial, because it then has these 1,3 diaxial interactions. And it has those 1,3 diaxial interactions with even hydrogens that are on the other axial position. So the most stable conformation is going to be the one where both groups are equatorial. And the least stable is going to be when both groups are axial. And then depending on the size of the group, we want that group to be equatorial. And so let's go through this and then we'll deal with number 2 and 3. So the most stable conformation would be the one where both groups are equatorial. That's this one. That's the most stable. And then the least stable is going to be where they're both axial, which is this one. So this one's number 4. That's the least stable. Okay. Now for the other two, we've got a sec-butyl and we have an ethyl. Which one is larger? Sec-butyl. So having the sec-butyl group being larger, it would prefer to be equatorial than axial. So in both of the trans conformations here, they have to be one axial, one equatorial. So in this case, this would be number 2 because the large group is equatorial. And then number 3 would be this one because now the larger group is axial. So now we've ranked them from number 1 to number 4. And so that's how we would do a chair cyclohexane problem that I might ask you on the, I'm going to ask you on the exam. There are other of these problems with narrated answer keys in the Monday folder. And so there are other problems with the narrated answer keys that you can try. But this is how we would analyze a cyclohexane molecule at chair conformations. And just a word of warning, you need to know your alkyl groups, because if you don't, you're not going to be answering my problem. You're going to be answering a problem that you make up, and I don't grade those.